Thank you very much. My name is David Blurton. I am from the United Kingdom, and I moved to Iceland 1.5 years ago to live here. And as a typical developer, the first thing I did was thought, right, I'm going to have to try to learn Icelandic. How am I going to do this? Should I A, spend lots of time studying with books in the normal way that you learn things? Or should I instead build a website? Spend hundreds of hours on that, avoiding the problem, and try and build a website to help people learn Icelandic. So obviously I chose option B. So I'm going to talk to you about a project that I've been working on in my free time to do with helping people learn Icelandic. But really this is just an example project because I want to talk about using Docker. How can we use Docker to help us with our development workflow and then all the way through to production? So how many people are using Docker for production work at the moment? I have companies where they're running their production apps. Okay, lots of people. And how many people are using Docker every day in development? Yeah, a lot less. And this is kind of what I want to talk about, is that until now it's been really difficult to use Docker for development. There's been a lot of problems with how many people have used boot to Docker, the kind of old way. And how many people enjoyed the experience of using boot to Docker? Yeah, it was we'll talk about some of the problems with that, and it's good news. Basically, everything's fixed. So just to give you a quick overview of the application I'm going to talk about, it's just an example, but it's very kind of standard app. We've got a Node.js backend that's going to serve our data in JSON format, and then we have a React app that just renders that data on the screen. So hopefully something that you'll be familiar with and something that you can translate to whatever your application looks like. So what's changed? What makes now the right time to use Docker in development? So basically, they've produced some new apps, Docker for Mac and Docker for Windows. And these work differently to the old one. So the old version was using virtual machines. You had Docker running in a virtual machine, and that meant that you had to have some special IP address to connect to it. You had a few quirks because it was running inside VirtualBox. So these new apps change everything. These are built on, they run on hypervisors. They're not running inside virtual machines, using something called HypeKit, which is an abstraction layer to create cross-platform hypervisors, which is probably the most crazy thing I've ever heard. The Docker command is now available system-wide, so you don't have to have this special Docker terminal, which is the old way of doing it. Just you can run Docker as a program on the command line from anywhere, like a normal application. And the containers are all bound to localhost. You don't have this special Docker machine IP that you connect to anymore. You can just access your containers, very similar to if you just ran your Node application with Node, you'd be able to access it from localhost. Same now if you're running it in a Docker container, it's available from localhost. The other thing that I'm going to fix, which is the other thing that I'm going to talk about that they fixed, which really makes the development story work, is that before there was a big problem with file watchers. Like if your files changed, it didn't get the notification that that file had changed, the file system event that the file had changed because the files were being copied into this virtual machine. But now they're using a hypervisor, they can use the real files, and everything works as expected. So, what do we need to do to run our application inside Docker? So the first thing we're going to do is write a Docker file. Who has written a Docker file before? Okay, great. So about half the people have written a Docker file before, so I'm just going to go through how to write a Docker file for a Node.js app, and I'm going to go through line by line to explain specifically why I do it in this particular way, and hopefully that will reveal a little bit about how Docker works. So all Docker images are based on a starting image. So this is what this first line is, from Node 6.4. You can specify the exact version that you want, which is nice. That gives us nice repeatable builds, and that means that when a new version of Node comes along, we're still going to be targeting the same build. So it's really nice repeatability. It means that if we try and build this in a year's time, when we're on Node 67, then it will hopefully still work. You also notice that it just says from Node. So normally your Docker images would have a namespace, so it would be for my images, it would be from David Blurton / Tala API. These ones don't have a namespace, and that means that they're official images. These are images that are being maintained by someone from the Node Foundation, and they're being kind of supplied as official images. So it's nice to have Node configured by someone who works at Node, and then you can just use it, and hopefully everything works as expected. This is how you set an environment variable in a Docker file. Here I'm just changing the npm config log level to 1 because the default is HTTP. It will print out every HTTP request it makes, which is probably more information than you need. We're going to create a working directory where we're going to keep our code. Basically what Docker is doing is it's wrapping up your application with a file system, and that file system contains all the dependencies that you need to run, whether it's a runtime environment, dependencies, binaries, anything that's on the path that you need. So we need to say where we're running from. So this is the working directory. This next line, I'm not really 100% on this, but it's been working really well for me. Basically, if you're using npm shrink wrap, something I discovered is that normally when you run npm install, it would look at the package.json file, read the dependencies from that, resolve them based on the constraints that you've put in there, unless you have a shrink wrap file. And then the shrink wrap file contains the exact version, the resolution of all the sub-dependencies that it should install. And I've discovered, although the npm documentation says it doesn't work, is that you can install from just a npm shrink wrap file. So why would you want to do this? Why am I not just installing from a package.json? The problem with the package.json is that it's become kind of a dumping ground for everything else that we do with Node. So you have scripts in there. And then lots of packages put their own configuration in there. So maybe you have your Babel configuration, maybe it's in a separate file. Maybe if you have some test runner, it's got some configuration in there. And the reason why that's important is that basically we're going to be, when we build this, any previous layer that's unchanged will be cached. So if we, for example, manage to get down to line 7 here, which we should hopefully always be able to do, say that our npm shrink wrap file hasn't changed from the last time that we did a build, then that means it can just skip this step. It will reuse the cache from that version. And when it comes to something like npm install, that saves a lot of time. We don't have to npm install again, even though we're creating a container from scratch. So the containers are immutable, but we can use cache versions of old containers, providing that we're convinced that they should be the same. So basically, I was having problems with, like, with a package.json, you would go to change a script, and then that would mean that you had to run npm install again, which seems like, obviously, you know that you don't have to run npm install when you change a script. Like, that doesn't make sense, but because this is just looking at, has the file changed? Like, if I copy a file into the container, and that file's changed, and that invalidates the cache for that level. So this is why you'll see this is a common pattern, and people will always copy in their package.json higher up in the file before they copy in the rest of the files. So then we run npm install, and then we copy in the rest of the application. We're going to expose a port. The application runs on port 8000, and then we define a command, how to start up the application. So this is a complete Docker file, and this is a Docker file which would be able to run our application here on this machine, and we could also use it to run in production. So let's go ahead and build it at great personal risk. Okay. Super simple to build a Docker file. We're going to just run docker build. This -t is a tag. I'm going to tag this image so I can find it again. You don't have to tag them, but then you just get like a hash that refers to this build, so it's difficult to find it again. And then dot just means where should I build from, what's the context of the build, and that's just the current directory. So the first thing it does is like figures out what files do I need to send to the build. And you'll see that it skipped all the way to step 6 straight away. And that's because I ran this before, and the npm shrink-wrap.json hasn't changed. There aren't any new dependencies, so we can just reuse the last dependencies. So this is really nice. Like we can build this image, and even if there have been changes to our application code, we don't need to reinstall anything. We don't need to download Node again. None of these things have changed. Okay. So let's run the image. Let's try out our application that we've made. So how do we do that? Docker run. This -it means that we're going to basically attach this terminal sessions here into the terminal session that's inside the container. And the reason we have to do that is otherwise you can't kill it, which is frustrating for demos. Then this next argument, -p, says we're going to take the port 8000 that's inside the container and map it to port 8000 outside the container. Next argument is the tag. That's the image that we just built. And then I'm going to override the command. So I have basically this last argument, I'm going to run my dev command. And that's going to run, instead of running it with npm start, it's just going to run nodemon so that we can watch for changes. So application starts up, watching for changes. Great. The problem is when I save the file, the application isn't reloaded. And the reason for that is because this copy operation is a one-time thing. We copied the files into the container, but now the container is done. It's immutable. It's not going to pick up the changes from outside. So this is no good for development. I mean, we could just stop it, rebuild the image, but this is a really rubbish experience for development. So how can we fix that? So try doing it a slightly different way. So exactly the same command as before, but now we have this -v flag. And what that's going to do is create a volume. We're going to take the current working directory, and we're going to map that as a file mount onto this code directory, which is where we're storing our code. That was the working directory here from before. And so this is just like taking the files that outside, just like on your regular file system, and they're going to act as like a network drive or a file share, if you like, inside the container. So that now it has the real files. And again, we're going to run nodemon so it can pick up file changes. And now when I hit save, nodemon rebuilds the files. And if we you can see that we have the new message that I just typed in there. So we've got live reload working. So this is kind of the steps that we want. So we have our application running inside the Docker container, running Node inside the Docker container. And the live reload is working. We can just continue our development as we always have been. However, it's going to be a bit of a pain to just always be typing these extra commands, like passing these flags. How can we do this nicer? So the next step is to write a compose file. This is a file that's interpreted by Docker Compose, which is a tool that Docker provides to run multiple containers. And what does that look like? So a Docker Compose file, again, is quite simple. It starts with version 2 because they added some extra features which weren't backwards compatible, so you can opt in to the new version of the file. We're going to define some services, and a service is just anything that you want Docker to start a container for. So in this case, we're going to define a service called API. And then basically each of these commands reflects the parameters that we had to pass to Docker to configure it correctly to run for development. So we're going to build from the current working directory, We're going to override the start command. This just runs nodemon. We're going to map the ports so that it's visible outside the container. And then we're going to do the same trick with the volumes. Now there's one problem with the volume that I did before. And the reason for that is that the node modules, which you might have installed on your Mac, for example, or on Windows, they may have binary dependencies which are built for that platform. And if you just copy your node modules into this Linux environment, they're not going to work. They're not compiled for the right architecture. So what we do here And this is the biggest leap of faith that you'll have to take for this talk, is we have 2 volumes. And we have the one that we just used, so that's the current directory outside on the host that's going to get mapped to this code directory. But then we're going to create another volume. This is a named volume. This is like quite a new feature in Docker, which I'm defining down here. There's no extra configuration for that, which just means it's going to create a regular file volume using the default driver. And then we're going to map that to a directory inside our other mount. So you have the Docker container, which has its own file system that's isolated. We're going to mount inside of that our files from our host. And then inside of that, we're going to stub out like a safe space for it to install the node modules for its own platform. And that means that when we run npm install on the side of the container, these node modules will end up inside this volume, and they won't get leaked outside back to your host. And so that allows us to, if you want, you can even run npm install on the host, have the node modules for Mac there, which is sometimes useful for running things like ESLint or like your dev dependencies. And then inside the container, it will have the same dependencies, but compiled for the Linux environment that it runs in. So that's how you can get that to work, and that allows you to kind of not be locked in to developing in Docker. Sometimes it's easier to have those actual node modules if you need to debug something or whatever. It works equally well if you're going to be kind of careful and commit to this, always running inside Docker. There's no problem with just having these files being on your hard drive. The problem is if you then try and run npm, that's not going to work because they're for the wrong architecture. You have the Linux files which have kind of come back onto your Mac as part of the file share. So this is the reason that I would recommend this approach, because the errors that you get are very strange when you have files compiled for the wrong architecture. They're not always obvious. So this kind of gives you the safety, and it allows you to switch back and forth more easily if you want to do that. So the only thing left to do is to run our app. And the way to do that is using Docker Compose. And we'll just use the up command, which says, take my Docker Compose file and start all the services in it. And of course, it didn't work, because it's still running. OK, no problem. All right. So you see we have this slightly different logging output, and it's just basically it's just prepending the name of the service. And then it has API 1, because there could be multiple instances of this. It's not so applicable for development, but obviously in production you might want to run multiple copies of a container and then load balance across them. So now we have this working, and again, we can connect to the container from the outside, and it gives us the message from before. So this is great. You can see we've had the log output from the HTTP request there as well. This is great, and like neatly wraps up all those parameters that we had to pass in. There are other options as well, obviously, but I think these are the most important ones for development. So how do you run a command that you would typically have to run outside the container, like you want to install a new dependency? Super easy. Docker Compose comes with a run command. So if we were doing npm install cores before, now we do Docker Compose run, the name of the service that we want to run the command in, and then the command. So what this would do is it would fire up the container, it would run this command, npm install cores, inside. So this dependency is going to end up inside that volume that we defined. This respects all the settings you have in your Docker Compose file. And basically, this is just a straight-up replacement where you ran npm install cores before. Now just do Docker Compose run API, npm install cores. And if it's too much typing, then you can just make some aliases to make that a bit shorter. It's quite easy to get used to. So the Docker Compose file is really nice because there's not really any overhead to creating extra services. So one thing that I like to do is just define another service that runs my tests. So this just creates another instance of the same container. Here I'm just changing the command. So now I'm running my tests with the watch flag. The watch flag works. It will rerun my tests because we're doing the same trick with the volumes to just mount the files inside. And we don't even have to install the dependencies twice. It's reusing the volume that has all the node modules in. And you can imagine defining more services. Maybe you could run your linter. And all of these will just show up in like a nice interleaved output. So you only have one command. I don't know about you, but before I did this, I used to have to open multiple terminals, like start up various things that had watches because they're long-running processes. And so now this allows you to have them kind of all together and to start them all up with just one script, Docker Compose up. There's one other really nice feature worth mentioning for the services. And I don't use this on my project, but obviously lots of people do use databases, so it's worth mentioning. So here's an example of how do we connect to a Postgres database in development. So normally most people would just install Postgres on their machine and then get it configured correctly, and then maybe if you want to use it with another project, you have to reconfigure it. And what this allows us to do is we can run Postgres inside a container, which gives us an isolated version of this database. It's super easy, like it's way easier than installing Postgres. We just put the name of it here. If I wanted to install MySQL, I just put MySQL, Redis. All of these have official builds, and they're all configured out of the box. So that's super nice. We can interact with this, we can configure this image, or like any additional configuration that we need using environment variables, and all of them just list the kind of configuration parameters. It gives you like a nice API onto this image. So here we're going to define some username and password, and then in order to persist the data that's in the database, we just give it a volume, and then this exposes a port here. You'll notice that it says expose. Before we had ports, and that defined a port mapping. And this time we're saying expose a port, but there's no, what is the port that 5432 is mapped to? So this is where we come to links. So you see that the API has a definition here, links to DB. What this means is that Docker is going to set up an internal network route between the API service and the database, and the database is not publicly accessible. This doesn't have a port you can connect to it from. And that's why it would be perfectly fine to have your username and password like this. This database is not accessible from anywhere else on the host or beyond on the public internet. How do you connect to it from the API? What it's going to do is it's going to create an entry in the hosts file of this container for DB, and then that's going to resolve to the database. So you can just do connect to server DB, and that will be filled in the host file with the link to wherever it's decided to run this and on whatever port. I really like this, and like if you're using some abstraction over your, say your SQL library, if you're using something like SQLite or whatever, and you want to try swapping out your database for something else, or you want to just say like, oh, what would it be like if we added Memcache or Redis or some other service like this? Super easy to just create a new entry in your services. You can connect to it really easily using the links. And if you don't like it, just throw it away, delete it from your config, and there's no damage done. So this is really nice. But when we're running in production, we're not having to worry about what ports things are running on. Everything has a name. And I really wanted to find a way to solve this problem of like, I want to have all my projects running on a local domain. And it turned out to be really easy. This was actually like way easier than anything else to do with Docker. This isn't to do with Docker, but I just wanted to go through this to just demonstrate how easy it is, and I was really surprised. These instructions are for Mac, but I assume it's easy on Windows. We're going to use DNS mask, so just brew install DNS mask. We just need 2 config files. The first one is the DNS mask config file, and that says that we're going to resolve the address, anything that ends in the top-level domain dev, to 127.0.0.1 to localhost. And that's where our containers are bound to. So this is actually enough. But at the moment, that means that DNS mask is intercepting every DNS request. So what we're going to do is create another file that tells the operating system, only use this to resolve requests that end in .dev. So this is this bit here is OS X specific. I assume you can do this on Windows as well. We're basically just saying here, if the domain ends in .dev, then use the name server 127001. So now, when you use any other site, when you go on facebook.com, it's going to be resolved using whatever DNS you had before. But if we go to a .dev domain, it's going to be resolved to localhost. So how do we actually get those requests that are coming with these names and get them to the right containers? So this, again, is actually really easy. There are two images that I know that solve this problem, and they solve it in the exact same way. They're completely interchangeable. I used this one, which is based on high availability proxy, because I was already running it in development, and it was easy. I just copied the config I had in development, in production, works in development as well. But there's another one that's based on Nginx. So if you're more familiar with Nginx, then that might be better. You can just read the config files, understand what it does. But we'd basically just add another entry to our services for the proxy. We're going to link it to all the services that we want. And then in each service, we're going to define just this virtual host environment variable that says, what request should I forward to this container? So basically, if the request looks like api.tala.dev, then this guy will forward it to it. We have some port mappings here, 80 to 80, 443. We can use this to do SSL termination. If you want to test out that all your HTTPS is set up correctly in development, very easy to just generate some dev certificates, give it to this proxy here, and he'll do the SSL termination for you, forward it on to the containers, exactly like you probably would do in production. The only mystery line here is maybe this bottom line, which we have a volume, which is a socket, what's going on here, and also somehow it's like from itself to itself, like what's happening here. This basically says that we're going to connect the Docker engine outside the container to the Docker socket inside the container, and that's so that it can watch for any changes in the Docker containers being started and stopped. And that means that both these images, the high availability one and the Nginx one, will reconfigure themselves automatically when services start and stop. So that's really nice, and it works exactly the same in production like that as well. There were two changes that I had to make to my Webpack config to get this working with this, which is just worth pointing out so that you don't get stuck on the same thing. The Webpack dev server has like this leaky, like before it would have said $localhost and then the port that you're running on. But now we can just change that to our development domain, which for this image is going to be tala.dev. And the development server doesn't bind to all interfaces by default, so we just need to put host 0000, so it's going to listen on both our Wi-Fi and also the Docker network. So here I have another Docker Compose file, and I wanted to just point out a couple more features which make it really nice for development. You can use alternative Docker file in development. Why might you want to do that? In the case of a front-end app, the situation for running in development is normally very different to running in production. So say you're running a typical Webpack build, you're going to be running it, want live reloading. But in production, you're going to compile all the files down to static, and it's going to be served by something completely different, maybe just Nginx, or you're going to put it on App Engine or whatever. I've been thinking about this, like philosophically, like a lot of the ideas around Docker is that it's the same in development as in production, same all the way through your pipeline. But I don't think it makes any sense to try and like force yourself to run the same image. I mean, like you could do this, so you could create a node server that serves your files statically in production, and then you have some if development thing, then run Webpack config, but really you're just masking the problem. You're not really running the same code in development and production. So I prefer to just have these separate configs, and then I have another entry down here, which takes my built files and copies them into an image running Nginx, and this is the same image that I'm running in production. This is just the built JavaScript files with the hashes and minification and everything, just so I can test out are there any problems. If you're developing as part of a team and you're going to adopt this workflow, one super nice thing is that instead of building the code locally, you can just pull down an image. So how this normally works is that you have a CI system that's building your images and pushing them to a registry. You can tag these with maybe the branch name, latest, maybe even the commit, so that you can find a specific one again. And that means, so for example here, I can just use a pre-built image of the API. I don't have to have the code checked out for the API. It's really nice if you have people working on different parts of the stack. But then when I come to do a feature which affects both the front end and the back end, I can just change this to change this image to build, maybe just point it to build, // wherever I've checked out my code, and then I can make my changes there. So it's really simple to switch between pre-built images, which means you don't have to have anything installed to get them running, and then to switch back to the regular development with the files checked out. And then the rest of this is exactly the same, just the proxy to forward to these things. So what's going to happen? Let's start it up. So you see we get a whole load of output on the start. That's just all the containers starting up together. If you have some kind of ordering thing, you can define one container depends on another so that they come up in the right order. You see everything has come up now. Webpack has said it's finished building. I'm going to just try and save this because I left the other one running, so it's probably not actually come up. Just to clarify, like the one I showed you first is like if I'm working on an API, I'm normally like developing using tests, so I don't have to run the front end. But if you're developing on the whole stack, then I have a different compose file which just starts up the whole stack. So depending on how your workflow goes. So. So it's not on localhost anymore, of course. We should be able to connect to it on api.tyler.dev, which we can. We should have another service that's running Webpack Dev Server, and that serves some HTML. And then if I show you that staging one, you can see that here this server line says Nginx, so that's being served by Nginx. And this is what the site looks like. You can search for Icelandic words. It will show you how these words change according to the grammar. You can access the API. Not with HTTPS. That will return the JSON. And you see all of these have got nice names. Oh, sorry, that's the real service. Let's go to the development one. Everything has a nice name. Everything's linked together. This guy's using an image to build. And Hester is Icelandic for horse, so you learned an Icelandic word as well. There we go. If I could find my slides again, I would say that's the end of my talk. The slides are on slides.com/David Blurton if you want to have a look at those config files, have a go at setting it up yourself. The code for this project is on github.com/Tyler Icelandsku. Maybe just go to the slides first, and then you can find this link. But if you're using Docker in development and you have some improvements to this workflow, I'd love to hear about them. So come and talk to me. Thank you very much.